So we're going to solve this first, then we're going to graph it. So first thing I want to do is isolate the absolute value. So let's add 4 to both sides. So that gives me the absolute value of 1 minus 2x has to be less than 3. And then if that's going to be less than 3, let's think about what that means. So for this to be less than 3, that means that this absolute value has to be either less than 3 or greater than negative 3. So we know that 1 minus 2x has to be less than 3, or 1 minus 2x has to be greater than negative 3. So if you're greater than negative 3, that's like negative 2 and negative 1. The absolute value of negative 2 and negative 1 is less than 3 because it's positive 2 and positive 1. If this was like negative 4, that'd be bad because absolute value of negative 4 is 4, which is bigger than 3. So the absolute value has to be greater than negative 3 or less than positive 3. So these are my two different things to solve. So negative 2x is less than, if I subtract 1, 2, divide by negative 2. I got a warning bell going off. I divided by a negative. I got to flip that sign. So x has to be greater than negative 1. Um, it's not really or, it's more and. It's got to be both. It's got to be greater than negative 1, and x has to be, let's see, if I subtract 1, negative 2x is greater than negative 4. Divide by negative 2. X has to be, well, I guess it could be or. X has to be less than 2. Okay, once again, divided by a negative 2. So you have to be greater than negative 1, and less than 2. So that's our range. So I'm going to make a little graph here. Here's negative 1, here's 2, and these are not equal to, so we're going to use the brackets. So to solve this, x has to be um, greater than negative 1 and less than 2. So here's negative 1, here's 2. You would be this region right here. And there we go.